Diverse non-aquatic animals must support their long axis as its orientation changes relative to gravity, and because this is especially ecologically relevant for arboreal snakes, we used brown tree snakes as our study species to approach this problem. To test the effects of body orientation as snakes bridge different gaps, we obtained EMGs from the three largest epaxial muscles, which, from dorsal to ventral, are the semispinalis spinalis, the longissimus dorsi, and the iliocostalis. During straight horizontal trajectories, all three muscles on both sides were very active when they entered the gap. As shown here, when the head touches the destination, activity of the more dorsal muscles nearly ceases, but activity of the ventrally located iliocostalis continues. Unequal amounts of left and right side muscle activity occurred when snakes turned horizontally. As shown by the blue region, the left spinalis is active without the right spinalis when the body first enters the gap and it is flexing to the left. During right turns, the asymmetric pattern of left and right side activity was effectively a mirror image of that during left turns. During right turns, large amounts of initial activity occurred on the right side, with little left side activity. Compared to the horizontal trajectories, the overall amounts of muscle activity were much less when snakes went vertically up. Unlike the straight horizontal trajectories, the initial, large amplitude activity of the spinalis was not sustained right up until the destination was touched. Barely any muscle activity occurred when the snakes bridged gaps vertically downward. Overall, the observed amounts of muscle activity corresponded well with the decreased gap distances snakes can bridge horizontally compared to vertically, and downward movement appeared to nearly be passive. Body orientation and whether snakes had one or two points of support affected muscle activity, and this system has analogous mechanical demands with many other non-aquatic vertebrates. Indeed, some of the muscular mechanisms used by snakes resembled those used by humans when they perform either back extensions or prone plank exercises.